In this lecture, we're going to be explaining integration by substitution. So it's the first method I'm going to be basically explaining. Last lecture, we just spoke about the concept of integration and how it's actually performed and all the rules and formulas that we should know while integrating. Well, in this lecture, we're going to be explaining integration by substitution. So let's go ahead and get started. So, not all indefinite integrals can be evaluated using the formulas of the previous chapter or lecture that I explained. Sometimes we may use a substitution method. The idea of this method is to change the given integrand into a form to which the basic formulas apply. We do it by introducing a new function. So, the substitution rule is very simple. You have your u is g of x and your du is the g of x, which is basically derived, and your integral of f of x, g of x, d of x is equal to the integral of f of u, du of u. So it's like, in other words, that you're basically substituting your f value here with your inside function g of x as f of u times your g of x, which is basically your derivative, as your du value. Okay, so this is another way of rewriting it. So in applying the substitution rule, we must be able to recognize a suitable composite function, which is f of g of x in the integrand. So we really need to identify or recognize this inside, which is g of x. Note that the integrand must also contain the derivative of the interior function, which is g derivative of x. Understanding this requires practice. We present it in the following examples. So this is the example A. So this is your u, which is x cubed minus 1. So your du as a derivative is 3x squared d of x. So this is your example A, which is x cubed minus 1, close the brackets, 5 times 3x squared d of x. So you have your integral, which is u to the power of 5. So that's the value inside. You can see that your u here, your g of x is x cubed minus 1. Your du of u, which is basically the derivative, is, your du would be 3x squared. And this is how you wrote it. And from there, you can simply integrate right away. You know that any function to the power, we add 1 to the exponent divided by the new exponent. So it's going to be equal to u to the power of 6 over 6 plus c. So in this case, you will simply afterwards just substitute the value of your u value that you substituted in the beginning, which was x cubed minus 1, and divided by my 6. Right? So this is it. That's the main concept. I hope it was clear to you how you can perform it. We're going to go over now to several examples in a nutshell, okay? So here in this example, you have 1 over 9x plus 6 d of x. So once you look at this, you need to determine, first of all, your u value. So your u here would be your 9 of x plus 6. Your du is a derivative, so you need to find the derivative. We've already did differentiation before, so you already know how to differentiate this value, which would be equal to a 9 d of x. Your d of x is simply, you need to rearrange this, because when you put it back into this equation, you should also replace your dx with the du. So in this case, it will be equal to du over your 9. So simply, you're going to put all the values that you did here, which is 1 over u, times du over 9, which is 1 over 9 times ln u plus c. So 1 over 9 times ln your u value, 9x plus 6 plus c. Then you have your example c. So you have integral ln x to the power of 5 over x d of x. So I have integral u to the power of 5 times du, which is u to the power of 6 divided by 6 plus c. Okay, then you have your example d, which is integral of cosine x squared to x d of x. So you have your x squared is u times your 2x d of x would be my du. Because we already know that the derivative of this value is 2x, so simply this already shown that it's going to be du. So after you substituted, now we can integrate. What's the integral of cosine? It is simply equal to sine value. So you have sine of u plus c. Now you can put your u value here, which is x squared plus c. All right, now we have the last example, which is example E. So we need to use an appropriate substitution to find e to the power of x divided by 2 plus e to the power of x d of x. So the solution, we try to substitute the denominator of the integral. So you have u is equal to 2 plus e to the power of x. Then your du value is e to the power of x d of x. So we have your e of x divided by my 2 plus e to the power of x d of x. So it's equal to integral 1 over 2 plus e to the power of x times e of x d of x. So again, you know that your 2 plus e of x is your u value. So you have the integral of 1 over u times your du value, because you know that the integral of this function is e of x. So now we can integrate anything. 1 over x is equal to ln u, so 1 over u ln u plus c. Then you can simply put this value inside of here. So we have a small remark. We need to observe that the integrals in example b and e could have been evaluated using this formula, which is integral f of x divided like the derivative of f of x function over the f of x, which is a main function. D of x can be simply integrated using the formula that we already know. So we know that 1 over 9x plus 6 is, if we put 1 over 9 as a constant outside, and you have your 9 value at the top over 9x plus 6, the d of x. So we can simply say that you can see that the top of the numerator is a differentiation of the denominator. So it's 1 over 9 ln 9 of x plus 6 plus c. So this is it for this lecture. Then we're gonna be proceeding with the integration by parts, and make sure to check the seminar to check the examples on integration by substitution.